So I'm Jean-Marc Reynaud. I'm a senior principal data science at Grainger. I've been interested in AI for a very long time, and I'm going to share with you some of the things that I find fascinating. So first of all, people talk about there's a lot of hype around AI. Is AI for real? Is it artificial general intelligence, or is it just because of things working better these days? Did Neo AI get a little bit wider? There's a ton of investment in AI. We're basically in the third boom related to machine learning, and it's really taken on this time, I think. People like the Google CEO say it's more profound than fire. McKinsey, more impactful than steam engine. And it's close to home because we all use Google. We all have a phone in our pocket that can access those resources. The question I was asked recently by upper management is, has the singularity already happened? It's all machine learning, right? The fact is the singularity is predicted to be in like 2045. And that would mean you have an actual AI emerging that could be changing how things work radically. On the hardware side of things, here NVIDIA has kind of taken over Moore's law from Intel. Moore's law is the doubling of performance every year or so. That's really happening in the GPU space. Now, the singularity has not happened, most likely, unless somebody has developed it in their garage or at Google. AI these days is really synonymous with deep learning. Deep learning involves GPUs and big data. What we thought of AI in the past, like things like translation, people used to say if you can do translation, then it's AI. Well, we can do it today, but now today it doesn't look like AI. Now, what do we think AI should be doing now for the next generation? And AI can definitely help you think, but so far it does not think. Deep learning is found in Python and uses GPU clusters. Deep learning is working today. Artificial general intelligence still lives in PowerPoint. Nobody has shared any code. The question is, will they? Yet the progress in the last 5 years in voice, image, and text is nothing short of amazing. Just a show of hand, who is familiar with word embedding? So a few of you. Word embedding, so if you're a data scientist and you're used to manipulating number, when it comes to text, you may feel a little bit out of your element. It turns out, good news, you can turn text into numbers and then apply some of the classical method or the new method to that. One thing that happened in 2013 is this thing called word2vec, which is a method to read a text like Wikipedia and take a sliding window of 5 words, eliminate the word in the middle, and try to guess it. By doing that, what they found happen is that the words move in a space and end up finding each other in terms of words that are semantically close will find themselves to be sitting in the same area in that space. Now that space is pretty large. I've illustrated here just in 2 dimensions. Things like a cat or dog would go very close together, or the verb sat and laid in that space. What's very interesting, and was the first fascinating thing for me, is analogy. So kitten and puppy are, young cats and dogs, and they're on a specific axis in that space. So you can do things like regular math on that, like cat minus kitten plus dog is equal to puppy. So, and that you can actually compute, and it's quite amazing. But what is word embedding? So typically in the English vocabulary, you have 30,000 words or so. Maybe using the web, there's maybe 500,000 words. But you can map them to an Excel spreadsheet of coefficients. Each column would be pretty much an aspect of the world. In this case, I've illustrated with animals, feline, furry, young, etc. This is really an artistic rendering, but in reality, the dimensions are a little more abstract, the columns. But they're very useful still. You can connect any kind of classifier onto that and do text processing. So here is a kind of a timeline of what happened in the last 10 years, roughly. It all started with ImageNet, and computer vision made tremendous progress in a few years right after the challenge to classify 1 million images in 1,000 classes. In 2012, AlexNet was the thing that put GPU and deep learning on the map for a lot of people. Soon after, natural language processing got a boost with Word2Vec, and also GLOVE, Doc2Vec, and fast text are techniques that are in great use today. What's amazing is that they've put actual people in fMRI machines and read them stories. While they were listening to the text, their brain activity was recorded, and it turns out that certain areas of the brain store specific meaning in closely located brain areas. So, and you can see colorized here the visual types of words are clustered in that part of the brain, in the frontal lobe. Social things are in different areas, and you can take the map, the brain, and actually flatten it and see a map. What's very curious is that even though we're all different, we seem to share relatively close map, and that brings me to what Elon Musk is trying to do, which is implant some electrodes in the brain in a safe way, and have a little device to talk to your laptop or your computer, and be able to basically enable people to send and receive thoughts. So, of course, that means we would be able to almost telepathically communicate in the future. This idea is actually realized in something called unsupervised translation. Alexis Kono at Facebook did that, taking Italian text and English text. You end up with 2 different spaces, and it turns out that if you align, the most frequent words together, and then you just need to push the rest of the stuff, and you can have basically a one-to-one map between the two languages and have unsupervised translation without pairs of translation from Italian to English. And you can do that with any language, potentially ancient text, alien language, maybe the animals, who knows. It turns out this idea of embedding text is actually very popular for other things. You can embed almost anything. Sentence, paragraph, documents, and because now you in that space you can find thoughts that are close to each other. You can do paraphrase, you can do semantic search, which is actually something Google and Bing have done recently. Question answering, recommendation, re-ranking of results, summarization. So anything can go to vector, vector can go to anything. So now it yields a myriads of AI application. You have images that go into vector. The vector are turned into text. That's image annotation. You can have potentially user, item, and query, which are common to e-commerce. So you have user to vec, query to vec, item to vec. And so that enables recommendations and things like that. In medicine, you can have medicines and disease mapped to vectors, and somehow you can find the best cure for a disease. And there's lots of fun applications, like you can draw something and it'll actually create a picture. You can also just type something and it'll create a perfect image of a red bird with a yellow beak standing on a branch. All of that contributes to what we call currently AI, which is still narrow AI. Of course, this is kind of a shallow savant, right? It's got bias from the history of the text that it has used to learn. It's got also not a really good knowledge of how the world works. And reasoning is still in its infancy. But maybe what we would like is not just a very smart robot, but something that can augment our own intelligence. Here I'm going to talk about something very practical that has happened in the last several years. Companies like Google and Facebook and Microsoft have the compute power now with the cloud and the clusters of GPUs, and also have access to enormous amount of data. Wikipedia is one of them, but it's only 50 gigabytes. The common crawl is actually hundreds of terabytes. They've created subset of that which are cleaned up and trained models, and they basically offer those models to you. You can download them and reuse them to your specific application by fine-tuning them on your small data set and maybe with just one GPU, or sometimes with CPUs. You create your model, then you have a downstream task to apply it to with a nice bump of accuracy compared to what you probably had before, using either machine learning or statistical approach or heuristics. Now, the models are getting bigger very, very quickly. It used to be 10 millions of parameters. Today, it's almost 20 billions of parameters. What's fascinating to me the last few weeks is T5, which is an 11 billion parameter model, can answer question without fine-tuning. So It's doing something similar to Word2Vec, where it's masking certain words, but it's also learning to answer questions. So it's kind of like a closed book test. Transformers is this category of new models. They all have named around Sesame Street. So it's called Muppetware. There is a lot of them, and it's just growing. There's some that are practical and faster, like BERT, Albert, all those things that you can run on your own laptop.
Will automatically end in a few moments. Please press any key to continue the meeting.
Okay.
It's a lie.
I'm going to press a key. So you have some specialized models also in science, in biology, and in medicine.
Your meeting will automatically end in a few moments. Please press any key to continue the meeting.
There's stuff for specific languages in French, Flaubert and Camembert, or for certain business domain, like LinkedIn has one and Salesforce. They all work
Your meeting will automatically end in a few moments. Please press any key to continue the meeting.
I told you Zoom is bossy. Continue, sorry about that.
Okay. And intelligence is changing. The way we are looking at it may be a little different than what we originally thought.
Goodbye.
Goodbye. So maybe we're not going to have full-blown AI, but something that's more useful. What's interesting is that Google Translate, for example, I guess, went from having 500,000 lines of code of coded heuristic to maybe 500 with a very big model. Jan LeCun said, intelligence is just the ability to acquire and apply knowledge and skills in pursuit of a goal. That may be what comes next. The thing too is explaining AI is difficult. And it's actually difficult to communicate. People have different view on many different things and use words and interchangeably for different meanings. What we need is the ability to have a dialogue with an AI, so we can adjust what we're saying. But when you look into it, intelligence is everywhere. There's intelligence in monkeys, belugas, octopus, crows, and bees. Some of that is something we'd like to see a system do. AI, despite all the hype, is actually used today for things that are very relevant. Recently, there was an antibiotic-resistant bacteria which may have found its match in something called halicin. This was done using similar techniques in a few hours, trying several thousand compounds. This can be scaled to hundreds of thousands of compounds and medical conditions, something that can never be done in a wet lab. In the coronavirus, something happened as well related to using vision convolutional neural network to detect images, CT scan, differentiate between the flu and the coronavirus. Also, infectious disease surveillance was successful in actually detecting coronavirus before the spread. There's some fun things you can try on your own. You can just Google talk to a transformer, and you can start writing some text and hit generate, and it will basically create a story for you. This is what OpenAI didn't want to release. because you can generate fake news with this. Or you can generate some interesting thing you would never think about. A very useful one is write with a transformer. So you can just write some text, hit tab, and get 3 likely follow to your text. I've written this little text extract, and everything that's gray was actually suggested to me. It makes perfect sense. Another thing is question answering. This is, you give it a text, and you ask question to the text, and it will find the answer most of the time. If it's a little bit ambiguous text, you can see its limitation. So that's kind of interesting to see where we're at. And that's it. Questions?
Questions? I think we've got a couple minutes for a few questions.
Would you mind sharing your presentation? Because that's very interesting when you write something and it automatically gives you a kind of idea or something that might be very interesting thing to work on.
So essentially, all presentations will be sent out to everybody who registers. So this, once 30 minutes, kind of wrapped in video, and that'll be sent out on site. Site to upload. Anybody else?
Do you have any coding examples?
Coding examples?
Yes.
So everything I've talked about is open source. So you can find it, and the timeline that I give you is giving a lot of the names of those papers. A lot of them are papers with code, so you can actually try it try to reproduce their results, and then try it with your own data once you master it.
Great, thank you.
Yeah. There's also tons of in red are the data sets. There's also a lot of frameworks in dark blue that are very useful. The hardware is making a lot of progress also. So you're welcome to try it.
I got a question.
Yep.
You had a slide on AI for good. What's one of the top concerns for AI for bad that wants to go?
Well, I think there are many. Obviously, fake news is a big one, but it also allows Facebook, for example, to detect fake news much more effectively, or fake accounts, actually. I think that was in the news recently. There's also things that are inherently bad as bias, right? So the bias that is in Wikipedia or another training data set is actually 10,000 books that have been written in different time period in the past where people had different bias, and sometimes openly. Those things are going to come and be definitely part of what you can see when you type text and you let it complete. Sometimes the text is going to be surprisingly, bad. So those are things that people are conscious about. Big companies have actually published principles around AI, like Microsoft, I think, and potentially others, to be respectful. But detecting bias is still a pretty hard problem. So definitely something to watch for. Also, the thing is it doesn't really know, it doesn't have common sense, right? So something that obvious for a 5-year-old is not obvious yet. And that's probably going to have a lot of progress with just observing life or observing videos and trying to predict the future is how you learn about, and it is frankly how a baby learns with blocks and things, how the world works.
Okay, all right. Well, Jean-Marc, thank you so much.
All right, thank you.